All right, financial math classes. Nope, wrong class. This is IM2. All right, IM2 classes. Today we're graphing quadratics, but this is what's called vertex form. Should have this written out. Vertex form. The reason why it's called vertex form is because it makes it very easy to find the vertex and access the symmetry of the quadratic. So last time we graphed them in standard form. That was the ax squared plus bx plus c. This is actually a lot simpler. This is actually, we're just going to be translating graphs from parent function. Pretty easy stuff today. But the vertex form would be, so our h and k from the formula here gives us the vertex. Yeah, let's move on. So starting off, so like I said, this is the vertex. So a times x minus h squared plus k. All right. What we're going to be doing is graphing a parent function. We're going to graph just a standard one, and then we are just going to shift it and translate it based on where to put the vertex. So we're not going to be doing big long tables like we were doing the last 2 days. This is going to be a little bit simpler. It's not going to be maybe quite as accurate as the other way, but we're going to get a pretty good sketch of these graphs. So starting off, let's graph the parent function of a quadratic equation, quadratic function. We did this a few lessons ago, the standard. So we make a table of values. So we're just going to square the x values here to get the y. So -2 squared is 4, -1 squared is 1, 0 squared is 0, 1, 4. And then I'm going to plot these points. So -2, 4 is here, -1, 1, 0, 0, 1, 1, 2, 4. And then here is what that parent function is going to look like. Just like that. So the transformation function, what that is going to be is a times x minus h squared plus k. So the important point is this vertex. The most important point is 0, 0, right? The generic shape is a parabola. The domain can be anything. So I'm going to put this in inequality notation. So it can go all the way to -infinity and all the way up to a positive infinity. So let me write that a little bit clearer. So the domain x can be anything. If we look at the range, the y values where it's going up and down, it's not hitting any of the negatives. So the y, it's going to be greater than or equal to 0, but it can go all the way up to positive infinity. All right. So what we're going to be doing with this is we are going to shift it. Adding and subtracting the h's or the inside the parentheses in this vertex form is going to be a shift left and right. So let me do some things. So this is going to be a shift left and right. The k's are going to be shift plus k's is going to be shifts up and down. All right. So we are just going to shift this whole thing. The a's, that's going to stretch it or shrink it depending on if it's going to be greater than 1 or not. And so let's look at some examples of how this is going to work. So we're going to graph. So what I'm going to do is those 5 points that we have here, I'm going to plot those on all these. I'm going to do that first. I'm just going to do it on each of these. So 2, 4. So I'm going to put where the parent function would be and do my best to connect the dots with dotted lines. because these are just placeholders. We are going to end up shifting these graphs around based on what's going on with that stuff up there. So here, and then again here. So if I was smart, I would have these parent functions ready to go before, but oops, that's okay. So here, and we've done this before. We've translated functions. If you want to go back and watch the video on how to translate functions, a k on the outside of the function, what this is going to do is the -6 is going to shift the whole graph, everything down 6. So I'm going to take this point, the origin here, and shift it down 1, 2, 3, 4, 5, 6. And then every other point is going to go down 6. I can kind of make sure it stays the same form. So these 2 points go down 6 as well, around there. And then this point down 1, 2, 3, 4, 5, 6. And then connect just like that. That's actually pretty good. All right. This one here, when it's adding or subtracting inside the parentheses, it's going to be a shift left or right, but it's going to be opposite of what you think. Since it's x minus 3, this is going to shift the graph to the right 3. All right, it's opposite when it's inside. It's opposite what you think here. It's exactly what it is. So all these points are going to go to the right 3. So 1, 2, 3. I'm going to put that point first, and then all these other points go right 3. So these 3 are going to be easy to put right there. I'm going to count 3 on this one. So 1, 2, 3. That's right here. Great. Thank you for. Oh, geez. All right, so, and then this point, 1, 2, 3. So just shift all the points right 3. There we go. And don't make a silly line off the edge. I'm not fixing that one there. That's good enough. All right, so here, +2 inside the parentheses. So remember, it's opposite way you think. It's horizontal, but opposite of the way you think. So it's going to be left 2. And then +1 is going to be up 1. 2 again. So up 1. So every point is going to go left 1, 2, up 1. So here is the new vertex. So these points are easy to switch. They're just one away. So put these, and so these each left 2, 1, 2, up 1. This one left 2, up 1. And then connect. And that's all it is. So what you want to do is start with the parent function, just those 5 easy ones. Look at what the transformation is doing and shift it based on the transformation. Here we're just going to practice identifying the transformations, and we'll say what the vertex and axis symmetry is. So here, this is going to be a shift up 5, and that's it. And let's just identify the vertex, because the axis of symmetry is just the x coordinate of the vertex. So the vertex, so it's going 0, 0. We didn't shift anything. So remember, in the parent function, the vertex is at 0, 0, right? The shift, we're just shifting that. So we go, the new vertex, we didn't shift in the x direction, so the x is still 0. We went up 5, so that's 5. So vertex is 0, 5. This one is going to be a shift right 2. And the new vertex, we shifted right 2, so the x value is 2. We didn't shift in the y direction, so the y is 0. This one here, that's a shift left 3. Remember, it's opposite what you think. And so the vertex is going to be Left 3, so that means it's -3. We didn't shift up or down, so it's 0. Y value. So here we didn't talk about this on the graphing, but what happens here with the negative, this is going to flip it over the x-axis. We can just flip it. And then the 4 in front, what that's going to do, just the 4, is going to stretch it. So there are two transformations happening. So the negative flips it, the 4 stretches it. Again, this is stuff we did early in the year. So you can go back and check out the video about transformation functions if you want a little bit of review on that. So here we have 2 transformations. So first, the 3 here is just going to be a stretch. And then this is going to be a shift up 3. And so the vertex, the stretch doesn't affect where the vertex is. It's only the shifts that do it. So the vertex can be at 3, 0. Actually, let me go back to this one. We didn't do the vertex on this one. The stretch and the flip do not affect the vertex at all. It's just 0, 0. Only the shifts are going to affect the vertex. All right, so this one, the 1/3 is going to shrink it. And then the -2 is going to be a shift right 2. So our new vertex is going to be at 2. And then we didn't do any y shifts in the y direction. So 2, 0. All right, so here, this is going to be a shift right 4, and then down 2. So the new vertex. All right, so right 4 is going to put the vertex at 4 in the x direction, -2 in the y. Because it's going down 2. Here, the 2 is going to be a stretch. The 3, so now it's going to be a shift. That's going to be left 3, since it's negative, up 7. And then the new vertex is at the point, since it's left 3, that's going to be -3 in the x direction, up 7 is +7. That's it. So here, this one looks tricky. If we actually rewrite this portion as a -1/2, it's a little bit easier to see what's going on with that value there. So negative over the 2, I can change that to a -1/2, and it's the same thing. So we have the negative flips it, the 1/2 shrinks it, the -2 inside the parentheses then is going to be a shift to the right 2, and then the +1 is a shift up 1. And so that is going to put our new vertex, right 2 is at a +2 in the x direction, up 1 is a +1 in the y direction. All right, so here we're going to do the opposite. We're going to be given the shifts, and we're going to write the equation for it. I'm just going to use y's. So up 7 is going to be a +7 on the outside. Left 3 is going to be a +3 on the inside. It's opposite what you want. So here, y is equal to, it reflects, so there's going to be a negative out front. It's right 9, so there's going to be parentheses. It's right, and so that needs to be opposite of what we think. Right would normally be plus, so it's going to be minus. What is going, what? -9. We go down 4, right 1. So we don't have anything out front to worry about, but we do need parentheses. Down 4 is going to be -4 on the outside. Right 1 is going to be -1 inside the parentheses. So we got quite a bit going on here. So there's no horizontal, so I don't need parentheses on this one, just an x squared. The reflect, so it's going to be a negative out front, shrink 1/6, so -1/6 out front, down 2 is -2. That's all there is to it. That's going to do it for this one. Next time we will be doing intercept form.